We've been analyzing network phenomena in which people imitate the decisions and behavior of others, right? So you see people making a certain decision, doing a certain thing, and maybe that conveys information to you and you act on it. Or maybe you realize that matching what they're doing would actually benefit you, and so you act on that. Now, in this process, actually, the role of network structure, right, the way in which people are connected to each other, has been somewhat implicit because we've really been thinking about situations so far in which people take into account, at least conceptually, what everyone else in the population is doing, right? So in our models, when someone's deciding which technology to choose, they think about matching what the entire population is doing. And they think about what fraction of the entire world is using a certain technology. Or when they're trying to make a choice between two competing options, they think about what everyone before has done. But of course, there's another level of resolution at which we could try studying imitation, right? Studying the copying of behavior. And that's not where you imitate, say, the entire world, where you sort of take a census of the whole world conceptually and think what they're doing, but where you try to imitate the decisions of your own neighbors in the network, right? Your friends in the social network. And the idea is that maybe in some contexts, it's actually more important to you to match what they're doing than to match what the whole world is doing. And this idea that maybe we should study things that spread locally, just between you and your friends, rather than globally, where you're actually looking at what the whole world is doing, this is the basis for a long-standing field in sociology known as the diffusion of innovations, the study of how new ideas or innovations diffuse through the links of the network. And it's really a story about looking at two different levels of granularity, right? So when we think about you and the decisions you make and why you're making them, we could think about you taking in the world as a whole, or we could think about you just taking in your own network neighborhood. And those really lead to two very different ways of reasoning. Now, we've seen a lot about what you can gain from reasoning at the full population level, where you take into account what the whole room, the whole crowd, the whole room, the whole world is doing. What do you gain when you just think about what your friends are doing locally in the network? Well, there are actually two sorts of things that we can now try to model that really were hard to model when we thought about things at the level of whole populations. One is the idea of understanding how a new technology or a new idea can gain a foothold if currently the whole world is using something else. Right? Because our stories so far have said that if I have a technology that everybody is using, and if there are gains to being compatible, then of course that technology has an enormously dominant advantage. Because when you're thinking about the value of different technologies, matching what everyone is doing is hugely valuable. And it does have an enormous advantage, but you have to ask yourself, how does any other new technology ever compete? How does it ever gain a foothold? Because we do know that sometimes giant monolithic technologies eventually come crashing down and are replaced by something else. And the argument that's made in the diffusion of innovations, in the study of network structure here, is to say that maybe the other one competes because it gains a small foothold in the network, right? A few people, for whatever reason, decide to try using it. And now other people who just want to match what their friends are doing, match what their friends are doing, and they also use this new niche kind of product. And so it spreads just a little bit. And it's almost like there was a tiny little spot in the network where this thing was kind of nucleating and it was growing because people were just copying their friends and they didn't worry that the entire rest of the world was doing something different. And eventually it starts growing more and more and it becomes actually a non-trivial force, and now it actually is competing with the big technology, maybe even sometimes at a global level, right? But the way it got started in the face of this monolithic opposition, right, this technology that was everywhere, is that a few people used it and they sort of carved out a little corner of the network. And you can actually model that, and we will model that quite accurately once you think about network structure. And related to that, there's a second kind of thing that we can think about when we think about the actual network structure, which is that often you do see two competing technologies or ideas that coexist. And you could ask, how did they divide up the world the way they did? And what we'll find is that what often happens is you can actually get different communities within the network, right, within the global network, and so that everybody feels like they're being compatible with their friends, but there are sort of these two clusters of friends and they're not interacting as much. And so one technology lives in one technology lives in another. And so you can find, for example, maybe that at the level of technologies, one industry uses one standard, another industry uses a different standard, but because those two industries don't interact very much, they can coexist, right? The people you interact with are always compatible with you. So that's the kind of things we can learn once we go to look at network structure. And we'll actually be able to carry this sort of informal intuition quite deeply into the models and see it pop up there. And to give sort of an idea of how that might work, I want to walk through a really simple example of how something might spread on a network when we take network structure into account. And then we'll go back and think about how we might explain why this model is natural and what some of its consequences are. Okay, so here's how the model is going to look. We're going to start with a social network. So we've got this collection of nodes who are all linked to each other. And you'll notice they sort of form these three natural sort of clusters, you might say, right? These two groups of 4 densely connected nodes and this group of 6 densely connected nodes, and right, nodes B, C, and D who sort of sit at the interfaces of these clusters. Okay, and let's imagine that all of them are using some kind of default technology, but there's this competitor that's coming in, and you have to decide, do you want to switch to the new thing, to the new technology? And let's say 2 nodes just plunge ahead and they just try it. They're just early adopters, and we don't know why they've decided to try it, but they did. Node A and node G. And now every other node in the network is going to make the following calculation. It's going to do the following reasoning. They're going to say, I don't care that most people are using the old technology. I will switch if at least half of my friends have switched to the new technology. Okay, if I see at least half my friends have switched, I too will switch to the new technology. So if nodes A and G have plunged ahead and they did it for whatever reason they did, but everybody else is using this rule, we can scan the network and we can ask, so who would switch in this situation? Well, E would switch because E has four friends in the network, A, B, G, and H, and 2 of those 4 have switched to the new technology. So E will switch. And actually, for the same reason, H will switch. 2 of her 4 friends have switched. B is sort of just barely hasn't, right? Because not willing to switch. So B has what, like, they have 5 friends, only 1 of them is using technology. So they're below their 50% threshold. They will not switch. But E and H will. Now what we see is F. F previously, there was only one of their three friends was using it. 1 out of 3 was not enough to get them to switch because they need to see half their friends using the new technology. But now 2 of their 3 friends are using it, A and H. So in the next step, F will switch. And now finally B, who we had looked at, who wasn't yet willing to switch, now actually B sees that 3 of her 5 friends are actually using it, and so B will switch. So what we saw, first of all, is that this new technology gained a little foothold in the network, A and G, and exactly like our sort of cartoon picture worked, it began to spread, right? Now E and H switched, F switched, B switched, and so now it's a sizable fraction of the network, right? It kind of gained this foothold as it gradually expanded. But the other thing that happens is this coexistence, because it's not going to leap across the link to C, and it's not going to leap across the link to D. C has 4 friends, of whom only 1 is using the new technology. Likewise for D. And there's no real progress that this new technology can make. And so what we see now is we end up in a state of coexistence. The new technology made inroads against the existing technology. It carved out this cluster where it got 6 people using it. But then it reached a natural boundary in the network, right? A sort of cluster boundary, and it can't go any further, and we get coexistence. And this is the sort of thing that we would like to try modeling more formally. We would like to understand, first of all, is there a model of decision-making under which it's natural that people apply this kind of a majority rule, where I say I'm going to look at my friends and go with whatever is in the majority, or I'm going to do it if, say, some fraction of my friends are doing it. Can we understand a decision-making process that would lead to that kind of a rule? And then secondly, can we understand what the consequences of that rule will be in the network structure? Is it really true in general that we'll see new technologies filling out clusters and then stopping when they hit some kind of a natural boundary? We'll in fact find out that all of that really emerges from the model that we're going to develop, and in the process we'll learn about a bunch of other things, not just how ideas spread, but also to go back to earlier ideas that we've seen, the difference between strong and weak ties, for example, and the ways in which local bridges can bring you into contact with parts of the network that are doing things differently from you. That's certainly what happened in our example here, right? B and C form a bridge, B and D form a bridge, and indeed each of them is now, through their friend at the other end of the bridge, seeing things that they themselves are not doing, right? They're seeing the opposite technology. They get a glimpse into this cluster that's doing things very differently, exactly the way we expect weak ties to operate. So we'll see all of these things come out of the model, and the first step will be to think about the kind of decision-making that goes into this and what processes that implies.